The Titanic was one of the largest and most advanced ships of its time. When it was built in the early 1900s, many people believed it was very strong and almost impossible to sink. The shipbuilders used the best materials they believed were available at that time. However, after the ship hit an iceberg and sank, scientists and historians began to question whether those materials were good enough. This section explains what materials were used to build the Titanic and how those materials failed during the accident. The main material used to build the Titanic was steel. Steel was used for the ship's hull, which is the outer body of the ship that touches the water. At the time, steel was considered modern and strong. The Titanic's steel plates were thick and heavy, and they were designed to protect the ship from damage. However, modern testing has shown that the steel used on the Titanic was not as strong in cold temperatures as today's steel. When steel becomes very cold, it can turn brittle, which means it breaks more easily instead of bending. On the night the Titanic sank, the ocean water was extremely cold, below freezing. When the iceberg scraped along the side of the ship, the steel plates did not bend inward as expected. Instead, they cracked and broke in several places. This caused small openings along the hull, which allowed water to rush into multiple compartments. Another important material used in the Titanic was iron rivets. Rivets are metal pins used to hold steel plates together. Thousands of rivets were used across the ship, especially in the front areas of the hull. Many of these rivets were made of wrought iron, not steel. At the time, this was common because steel rivets were more expensive and harder to produce in large numbers. Later investigations found that some of the wrought iron rivets contained high levels of slag. Slag is an impurity left over from the metal-making process. Too much slag makes iron weaker and more likely to snap under pressure. When the Titanic hit the iceberg, many rivets popped out or broke. This allowed the steel plates to separate slightly, creating gaps where water could enter. The combination of brittle steel and weak rivets made the damage much worse than it could have been. The iceberg did not cut a huge hole in the ship. Instead, it caused a long line of small cracks and openings. These small openings flooded 6 compartments of the ship. The Titanic was designed to float if 4 compartments flooded, but 6 was too many. Once this happened, the ship was doomed. The shipbuilders also used bulkheads, which are walls inside the ship meant to stop water from spreading. These bulkheads were strong, but they did not reach high enough. When water filled the front compartments, it spilled over the tops of the bulkheads into the next sections, like water flowing over steps. Stronger materials alone might not have saved the ship, but better design combined with better materials could have slowed the flooding. It is important to understand that the materials used on the Titanic were not considered poor quality at the time. Shipbuilders followed the standards and knowledge available in 1912. There were no modern testing methods to check how steel behaved in freezing water. There were also no strict rules about the quality of rivets. The disaster showed the limits of the technology of that era. In summary, the Titanic was built with steel and iron that were normal for the early 20th century. However, these materials had weaknesses, especially in cold conditions. The steel became brittle, and the rivets were not strong enough to hold the hull together under stress. These material failures played a major role in how quickly the ship flooded and sank. If the Titanic were built today, it would use very different materials. Modern shipbuilding has improved greatly because of better science, better testing, and lessons learned from disasters like the Titanic. This section explains how modern materials might have changed what happened and whether the Titanic could have survived with better construction. One major difference would be the type of steel used. Modern ships use steel that is specially designed to remain strong and flexible even in very cold temperatures. This steel bends instead of breaking. If the Titanic had been built with modern steel, the hull might have dented when it hit the iceberg instead of cracking. This could have reduced the number of openings in the hull and slowed the flooding. Another improvement would be steel rivets or welding. Today, ships are mostly welded instead of riveted. Welding joins metal plates together in a continuous bond, which is much stronger than rivets. Welded seams are less likely to separate under pressure. If the Titanic had welded joints or stronger steel rivets, the plates might have stayed in place even after hitting the iceberg. Modern ships also use quality control testing. Every batch of steel and metal parts is tested for strength, flexibility, and resistance to cold. Weak materials are rejected before they are ever used. In 1912, this level of testing did not exist. If Titanic's materials had been tested the way modern materials are, the weaker rivets might never have been installed. In addition to better materials, modern ships use double hulls. A double hull means there are two layers of steel with space between them. If the outer hull is damaged, the inner hull can still keep water out. The Titanic only had a single hull. If it had a double hull, the iceberg might not have caused flooding in so many compartments. Modern materials also allow for better bulkhead design. Today's bulkheads are built higher and are fully sealed. This prevents water from spilling over into other areas of the ship. Even if the Titanic had suffered damage, stronger materials combined with better bulkhead design could have kept the flooding contained long enough for rescue ships to arrive. However, it is important to say that materials alone may not have saved the Titanic. Other factors played a role, such as speed, lack of binoculars, poor communication, and not enough lifeboats. Even a ship built with modern materials can sink if enough mistakes are made. Still, better materials could have given the ship more time and a better chance. Scientists who have studied the wreck believe that if the Titanic had used modern steel and construction methods, it might not have sunk at all, or it might have stayed afloat much longer. Even an extra hour or two could have saved many lives, because nearby ships might have arrived sooner. Modern materials are much stronger, safer, and more reliable than those used in 1912. If the Titanic had been built with today's steel, welding, and design standards, the damage from the iceberg would likely have been less severe. While it is impossible to say for certain that the ship would have survived, it is very likely that better materials could have reduced the damage and saved many lives.